Large language models or LLMs are everywhere today. They power chatbots, personal assistants, content generation, and so much more. Whether it's a chatbot helping with customer service or an AI that generating articles, LLMs have revolutionized how we use machine learning in real life application. But there is a huge limitation for these typical LLMs. So what is that limitation? Before coming to that, let's talk about LLMs. Large language models are AI systems capable of understanding and generating human language by processing vast amount of text data. These models are trained to understand and generate text. LLMs like ChatGPT or GPT-4 are designed to answer questions, write essays, create stories, and explain complex ideas, all by learning from a huge amount of text data. This process of learning from tons of text makes the model highly skilled and responding to questions, creating stories, or explaining things in a way that it feels natural. Then, what is the major limitation of these models? Once an LLM is trained, it has a sort of knowledge cutoff, meaning it knows everything up until a certain point in time, but it can't learn anything new unless it is retrained. Let's say an LLM was trained up until early 2023. If someone asks who won the 2024 presidential election, the model won't be able to answer accurately because it doesn't have any information past early 2023. It might give general information about past elections or explain how elections work, but it won't know who the winner is because that information simply wasn't available during its training. This is what we mean by a knowledge cutoff. The LLM is only as knowledgeable as the latest information it was trained on. It can't assess anything new unless it is retrained with recent data. Imagine a company uses a chatbot powered by an LLM to help with customer support. The chatbot was trained up until early 2023, so it's great at answering questions about products, policies, and promotions that were available up to that time. But now, let's say the company just launched a new product line last month or recently updated their return policy. If a customer asks the chatbot, "Can I return the new smart home product if I am not satisfied?" the chatbot might give outdated information. It could reference the old policy or say nothing about the new product at all, simply because it doesn't know about these updates. This outdated information could frustrate customers, leading to confusion and possibly even lost sales. So what would be a solution here? RAG, Retrieval-Augmented Generation. Retrieval-Augmented Generation enhances LLMs by introducing an intermediate up-to-date knowledge source. When the model receives a query, it retrieves relevant current information from this source and combines it with its own understanding to provide an accurate, relevant response. Let's take a real-life scenario to understand this concept more clearly. Alex, he is planning a trip to New York City. So he is asking his friend Bain about some places to visit there, because Bain knows more about the city. Bain provides some details about the places that Alex can visit, but Alex needs new attractions or restaurants that have opened recently, but Bain doesn't know about that information. So he asks his friend Chris, who keeps up with all the newest sports and events in New York City. So he contacted with Chris. Chris shares the latest information with Bain, and Bain shares this data and the information that he already knows with Alex. In this analogy, Alex is the user, Bain is the LLM, and Chris represents RAG. In the RAG architecture, two key steps will occur: retrieval and generation. First step is retrieval. These steps involves searching for relevant information from an external source such as database, knowledge base, or the internet. When a query is made, the system retrieves the most relevant documents or snippets from these sources based on the question or topic. Second step is generation. Once the relevant information is retrieved, the generation step is performed by the LLM. The LLM takes the retrieved data and generates a response that is coherent, contextually appropriate, and natural sounding. In this step, the model combines its built-in language skills with the newly received information to produce an answer that is both knowledgeable and relevant to the user's question. The RAG framework typically uses a vector database for storing up-to-date information. So what is vector database and why it prefers over other databases? A vector database is a specialized database designed to store and manage data in the form of vectors. Vectors are mathematical representation of data such as text, images, or other type of data converted into numerical format that capture the meaning of the text in a way that it is searchable and comparable. In normal database, data stored as it is. For example, the number 125 can be stored as an integer, and the words cat, dog, etc. can be stored as a string. But in vector database, each word is assigned a vector array of numeric values that represent the word. Words that are semantically similar end up close together in the vector space, allowing vectors to encode meaning based on the context. So using vector database, we can store these vectors. How can we convert these words or sentences to these vectors? Vector embeddings. Vector embeddings are a way to convert words and sentences and other data into numbers using text embedding models. To convert words or sentences into vector, we need a machine learning model trained to generate text embeddings. Some popular models include Word2Vec, BERT, OpenAI embeddings, etc. Once these vector embeddings are created, it can be stored into the vector database. In a RAG architecture, when a query such as a user question is received, it is first converted into a vector embedding using the same embedding model that was used to encode the documents. This query vector is then sent to the vector database, where it searches for the nearest neighbors, the most semantically similar vectors. In a traditional relational database, when we search keywords, it will query terms exactly as they appear in the database. But in the vector database, it's semantic search, means a search approach that understands the meaning of the query and retrieves relevant information even if it doesn't match the exact terms. Basically, it returns similar vectors. Similar vectors indicate semantically similar content. For example, if you search for fixing my computer, in semantic search could return results for laptop repair, as it understands both queries are related. The vector database quickly retrieves the top relevant content and return them to the RAG pipeline. The retrieved documents provide contextual knowledge that the language model can use to generate a more accurate and context-aware response. In the RAG setup, the generation model takes both the original query and the retrieved documents as input, and the LLM model generates a response for the user using the specific information received. If we break down the RAG pipeline, there will be 5 steps. Step 1. User query. A user asks a question. For instance, what are the latest trends in renewable energy? Step 2. Query embedding. The query is converted into a vector using an embedding model. Step 3. Vector database search. This query vector is used to search the vector database. The database retrieves the most relevant data. In step 4. Augmented generation. The generation model receives both the original query and the retrieved context. It uses this combined information to create a response that is both accurate and informative. Step 5. Output. Model generates a response for the user using the specific information retrieved. So in conclusion, Retrieval-Augmented Generation combines the strength of retrieval systems and language models, offering key advantages for application requiring accuracy, relevance, and scalability. By retrieving up-to-date information from an external vector database, RAG ensures responses are both current and contextually grounded, reducing the risk of misinformation. So that's all about today's video. In the upcoming video, we will implement the RAG pipeline using Python and Llama model. If you like the content, please consider to support the channel. Thank you for watching and see you in the next video.